Hello, good morning. From the electric circuit analysis, I am going to take a unit 5, that is a DC transient analysis. So here there is a AC transient analysis also there. So from that I am going to explain about DC transient analysis, the first one. So these are the topics comes under that your DC transient analysis: natural response of RL circuit, natural response of RC circuit, step response of RL circuit, step response of RC circuit. The main objective of this DC transient analysis is to investigate the behavior of currents and voltages when energy is either released or acquired by inductors and capacitors, when there is an abrupt change in DC current or voltage source. To do an analysis of natural response and step response of RL and RC circuit. The next one. This is a first order circuits, a circuit that contains only sources, resistor and inductor, that is called as a RL circuit. A circuit that contains only sources, resistor and capacitor is called as an RC circuit. RL and RC circuits are called first order circuits because their voltage and currents are described by first order differential equations. The next one. These are the things we have discussed, that an RL circuit, it contains sources, resistor and inductor, and RC circuit, it has the sources, resistor and capacitor. And then any first order circuit can be reduced to Thevenin's or Norton equivalent connected to either a single equivalent inductor or capacitor. In steady state, the inductor behaves like a short circuit. In steady state, capacitor behaves like an open circuit. The natural response of an RL and RC circuit is its behavior when stored energy in the inductor or capacitor is released to the resistive part of the network. So natural response, mainly the voltage and current behavior only, your resistance, inductance or capacitor will behave. So mainly it is a stored energy only. So after that the current or voltage passes through the resistive, either it can store or else it can send to the another terminal or like that. The step response of an RL and RC circuits is its behavior when a voltage or current source step is applied to the circuit or immediately after a switch state is changed. Switch state is changed. This is a natural response of an RL circuit. Consider the following circuit for which the switch is closed for t less than 0 and then opened at t is equal to 0. The DC voltage V has been supplying the RL circuit with a constant current for a long time. Here the circuit has a current, resistor output resistance, and then a resistance and inductor. Here the circuit has closed and then totally the voltage supply is passed that with a constant current for a long time. So this is the equation for t less than or equal to 0, I of t is equal to I naught. For either a t greater than 0 means the circuit will be reduced. So before the circuit there is a switch, it will be acting that if the t is greater means that switch will be automatically deleted. So the notations O minus is used to denote time just prior to switching. O plus is used to denote time immediately after switching. So here there is, from the diagram we are applying the KVL to the circuit. The first voltage source V of t plus or I of t current, that is equal to 0, first equations. And then for applying the voltage we are using the self-inductance circuit. The self-inductance circuit, it has maintained that the number of turns is passing through the current and then flux will be produced in the output. So that we are taking the equation L di of t divided by dt plus or I of t, that is equal to 0, and afterwards that plus sign or I of t will be move on to the next side. There is a minus or I of t, third equation, and then we are getting the current there, so that I of t will come to the numerator or denominator of the di of t, and then that is equal to minus or divided by L d of t, your fourth equation. And finally the fourth equation we can write it as I instead of u. So du by du is equal to minus or divided by L. So we can differentiate that, and afterwards we integrate both the conditions, and we are getting that is a current source with the corresponding to the T naught. So that is that oral circuit total equations. Thank you.